Solvay Specialty Polymers in Alpharetta, Georgia is a global advanced materials and specialty chemicals company. The Alpharetta location makes specialty high-performance polymers for medical, automotive, and specialty applications. Because this is a research facility, pictures and video were closely monitored and some details were guarded. Solvay produces the raw materials that other companies use in various processes, but they must be able to use those processes on site to test their materials. Extrusion is used to create filament, which is then chopped to create the pellets for molding. They use injection molding to create samples of their customers' polymer for research and development within different labs throughout the facility. Tests may include environmental stress, cracking resistance, mechanical properties, etc. To begin the tour, we had to first watch a safety video and acquire the proper PPE. This included steel-toe boots, a flame-resistant lab coat, and safety glasses, at times requiring heat-resistant gloves and earplugs.
Pellet extrusion is how the raw material for many plastic manufacturing processes are made. Pellet types depend on the different base resin that is used during manufacturing, and pellet size is also dependent on the material being produced. The raw materials for the pellets are fed into the extrusion screw through a hopper. Additives can be mixed in at exact points along the screw to reinforce the material, change the chemical composition, or for color. The extrusion screw gradually mixes, heats, and compresses the materials together. While the barrel is heated, the majority of the melting is done by the compressive action of the screw. The screw forces the mixture through a die and onto a cooling conveyor. The resulting filament is shredded to the specific size for the pellets.
These pellets go on to become many different plastic products. One of these products is plastic filament, as used in 3D printing. To create these long strands, the plastic pellets are fed into a hopper that deposits the pellets into a barrel containing a screw similar to the previous process. As the screw rotates, pellets are transferred through the length of the barrel, where they gradually heat up. By the time the plastic reaches the end of the barrel, it's melted to a consistency suitable for extrusion. As more plastic is added, the pressure forces the melted plastic through a nozzle. This process is what creates the long continuous strands of plastic that will get spooled up. For the process to be successful, various factors need to be closely monitored. Adjusting the temperature or speed of extrusion induces a change in the torque required of the machine.
Another use for the pellets produced in the first process we mentioned is injection molding. Like before, the pellets are loaded into a hopper. The hopper funnels these pellets into the barrel where the screw transfers them forward. As the pellets move through the barrel, they're heated in a similar manner as before. By the time the plastic reaches the end of the barrel, it has been sufficiently melted. This melted plastic builds up until the correct volume is present to inject. The screw lunges forward, transferring the plastic from the barrel into the mold in a fashion functionally similar to a syringe. A check valve on the screw tip prevents the material from being pushed backwards along the screw.
The pieces being produced at this facility were scientific test pieces destined to be analyzed in the on-site labs. Tensile test bars are used to create a stress-strain curve for the material, which can provide yield stress, ultimate stress, and modulus of elasticity. These bars have gates on each end so that a cold knit line is produced in the center of the part, a worst-case scenario for the strength in a successful molded part. Color chips are molded in order to test the optical qualities and durability of the material. Tests for reflectivity, color, and resistance to UV damage are performed on these parts. This example has the runner and gate still attached. Absorption pucks are simple round discs of material that are weighed before and after soaking in water to test how hygroscopic the material is. While this facility is not producing final products for the market, these pieces are vital to understanding the properties of the materials that will make up many diverse products.
Touring Solvay Specialty Polymers was a valuable learning experience. We were able to get a general overview of several plastic production processes from making the raw material itself to molding a finished product. Thank you, Solvay.